This video is going to cover some common measures around vaccines, including vaccine efficacy, effectiveness, and coverage. So this is just a review of what immunization looks like. This is just kind of the natural way we're going to go through first. So after your first exposure, you're going to mount a pretty small immune response, and it's probably not going to be enough to prevent you from getting sick. But basically, the next time you encounter that agent, you'll mount a much larger immune response. And basically, what's happening here, the difference between the two is the first time you fought the infection, your body, like, basically your white blood cells took like what the virus or bacteria looks like, and created a bunch of antibodies and new white blood cells that are capable of recognizing that as the agent and recognizing it as something they should be killing. And as soon as they encounter it, they can upregulate a bunch of defenses that are specific to that disease. Well, the first time you encountered it, it didn't set off as many alarms because your body wasn't able to recognize it as a threat, but this time it can. And the difference here is that you're able to mount such an effective immune response that you typically don't actually get disease. Your body just fights the little exposure of infection you got, and the infection never really takes hold. And instead of this is the example of just being infected, the common way where you don't amount a sufficient immune response and you get sick, but the analogy of vaccination is essentially like putting you through this, like getting you this immune response that can turn into adaptive immunity, but doing it in a way that doesn't make you actually sick. So a way you can do that is attenuate the virus or bacteria so it's not strong enough to take hold, because all the white blood cells really need is like the shape of the bacteria or the shape of the virus in order to remember it, or just killing it. Yeah, for that same reason. There's other components you can use, like the COVID one was an mRNA vaccine, and that's just like a component in like the replication of the virus. It's not even like a structural thing. So efficacy is something that people want to evaluate for their basically when they're trying to develop their vaccine, because it's happening in kind of perfect situations like a randomized control trial, and it's the proportion of cases that are prevented by their vaccine. So it's yeah, so it's easier to see with an example, and I'll get to that in a second. And this one, because it's happening under ideal conditions, isn't really susceptible to as many like real world biases. In effectiveness, that's the basically the proportion of cases prevented by the vaccine in real world conditions, and that's done with observational studies like cohort studies or case controls. And that does have the issue of volunteer bias, just because the type of people who go to choose to get vaccinated might not be at the same risk of getting infected, like not even due to the vaccine, just because of that health seeking behavior. They might be more likely to avoid situations where they're likely to get infected, or avoid behaviors that are likely to get them infected. So that this vaccinated and non-vaccinated group is just not comparable sometimes, and you just need to account for that. One way people do that is using test negative studies, where to get into the study, you need to have gone to the doctor's office and gotten tested for the disease in question, and test negative. And those who choose to be vaccinated after that are in the vaccinated group, and those who choose not to be vaccinated are in the non vaccinated group. There's all these other reasons that basically underlying why they chose to be vaccinated or not that might influence like their likelihood of getting disease, but this kind of controls for that health seeking behavior. And yeah, effectiveness is this ongoing thing, and pretty much whenever you see effectiveness and efficacy, even in other contexts outside vaccines and epidemiology, efficacy is usually like the idealistic version, and effectiveness is like accounting for some of those like behavioral imperfections and stuff. Like if it's evaluating like the effectiveness of a medication, like effectiveness would basically use a population where people are sometimes just like intermittently stopping the medication, because with observational studies it's just real patients just taking medication the way they would in the real world, which is typically non-ideal. Sometimes they're stopping the medication or taking more of it. So this is just going over how to calculate vaccine efficacy. So in this 2 by 2 table, you can see that in the vaccinated group, 5 people got sick out of the 50. And in the unvaccinated group, 40 people got sick out of the 50 people in that group. So it's a relative risk where the exposure here is vaccination. So the risk in the vaccinated group, 5 over 50. Risk in unvaccinated group, 40 over 50. And it comes out to 0.125. The VE, we just use VE just to basically whether it's efficacy or effectiveness is context dependent, like on what design it is. But does VE do account for like both, just evaluating a vaccine? If you do one minus that, then you would get this value that's more interpretable. That's 88%. So basically, 88% of those who got vaccinated um, had the disease prevented through vaccination. Vaccine coverage. This just before we get into vaccine coverage, something to talk about is just that there's a whole other video on R naught, but R naught is the number of people that an infected person is expected to go on to infect. So an R naught of 2 means that everyone who gets infected on average is expected to infect 2 other people. But X is something that we can use to account for like the fact that not everyone in the population is susceptible. So this effective R naught is R naught multiplied by the proportion that are susceptible, basically. So just an example of that, if we have a population where 80% of people are vaccinated, so only 20% of people are capable of getting the infection, presuming that it's like a perfect vaccine. And if we have an R naught of 2, so taking all that into account, what's the effective R naught? So it would be the R naught 2 multiplied by the proportion of the population that's still susceptible. So that's 0.2 of the population, because only 20%, or sorry, 20% are not vaccinated. And the reason that this is useful and how this relates to what I was just talking about, vaccine efficacy, and how R comes into this, is that where an R value is, or effective R is what this R is, where it is relative to 1 is important for how the epidemic is going to progress from that point. So if R is above 1, that means every person is infecting like 2 other people, so it's growing, it's an epidemic. If it's 1, that means everyone is infected, typically infects 1 other person, they're just replacing themselves, it's in this equilibrium state. And if R naught is less than 1, it's not that you infect like half a person or a quarter of a person. It's just that not everyone goes on to infect another person. And that is the one that people are always trying to reach, just a situation where R has become less than 1. And people are often want to know like how many people need to be vaccinated for that to be the case, for R to be less than 1. So this is some of the information you need to figure that out. So FV is this new variable I'm going to describe. It's the fraction that are vaccinated. Yeah, just the number of people vaccinated, or the number of people eligible to be vaccinated. And just remember this effective R naught equation, R naught multiplied by the number susceptible. 1 minus FV, that's just the proportion that are unvaccinated, which is the exact same thing as the proportion susceptible in this case. Rearranging that and like solving for the inequality of this, like it needs to be less than 1 thing. You can come up with this formula for the basically your fraction vaccinated needs to be larger than this value that's based on like the R. And obviously, not every vaccine is fully effective, as we learned earlier with the VE equation. So you can incorporate vaccine efficacy or effectiveness into that, and that's basically the less effective a vaccine is, the larger coverage you're going to need to get the same like effect.